Okay, so in this video, I'll be going to illustrate to you how the heap sort, insertion, and deletion work. So in your sorting technique, you will be going to follow how does it work in step-by-step manner. So first thing, you will be going to insert. Since in your insertion, you have to go ahead and create a, what do you call this one? You really need to create a complete binary tree. So right now, in your you have to make sure to indicate what you will need to do. So first step, you have to insert the 10. So it will be something like that. And your axis here will be 10 as well. So you can somewhat do like that. Or we can say, it's okay if you will do something like that. Then afterwards, the next step, you have to insert the next number, which will be the 27. So for that one, 10, then 27. So since in our heap sort, we are following the max here. So it must be the largest element will be at the top most. So in this one right now, it will be 1027. So what you will need to do, you have to make sure that 27 will be, you have to bring that up. So you will not be going to indicate another steps since you are still in the insertion of 27. So you just have to indicate that you will be going to bring that 27 up. So what you will need to do right now, 27, and then bring down this 10. So you will also swap them. It will become 27 and 10. So that's how easy you will need to do that. Next step, you will be going to insert the 36 right now. So inserting 36, you will be going to, since in our complete binary tree, you will be going to insert from left to right. So right now here, you will be inserting 36 by into the rightmost. By we call them like that. So it will become 27, 10, and 36. So you will be going to check in that specific tree if that follows with the max heap, but it does not. So what you will need to do, you will begin to interchange 36 and 27. So you will be going to bring that up, 36, then 10, then 27 will go down. It will become like that. And you will also swap 36 and 27. So what will happen in your box of array? That is 36, then 10, and 27. Must be like that. Then afterwards, after inserting the 36 right now, you will insert the number 5. So inserting number 5 right now, you'll be going to check in your array and your tree. Since you in your complete binary tree, that must be having 2 child in every nodes. So since it's already 2, what we'll need to do, you will be going to insert that into the leftmost of that specific tree right now. So in your 36, there is a subtree of 10. So you will be going to insert that right there. So inserting the element number 5. So what we need to do, 36, 10, and 27, and you will insert here the 5. So you will also check if that follows with the binary, the max heap. So that already follows, and that does not contradict with the rule. So you will also print out here a table, 36, 10, 27, and 5. So there will be no changes will happen for that. Then next step, since we already inserted number 5, we'll insert number 4. Inserting number 4 will be at the right after 5. So 10, 27, then 4. That is 27. Sorry. Okay, then here 5, then 4. So you will check if that follows max heap. Yes, that follows. So there will be no changes will happen for that one. So next step, you will insert right now. Next element will be 3. So in your 3, by inserting 3, following that one, you will be going to insert that at the right sub 3, which will be in the left side. So 10, 27, then 5 and 4. Then insert at the left of the sub 3, the 3. Then update here the element 5, 4, then 3. Then by checking that one, if that follows with the max heap, yes, that still follows the rule. Then, since there will be no contradiction will happen, we'll insert the number 9 right now. So for number 7, insert 9. So for this one right now, here 36, 10, 27, 5, and 4, then 3, and 9. So if you will begin to check, there's no contradiction will happen. 36, 10, 27, 5, 4, 3, and 9. So afterwards, you'll be going to proceed with the last one, inserting 14. So by inserting 14, that will be in the 8. Insert 14. So where you will begin to insert that. So at the left side, since both of your subtree do have contains already 2 elements, so you cannot insert that right side already since we're just basing with the binary 3. So here right now, what will happen? 10, 27, then 5, 4, then 3, 9, and you will insert the sub 3, 5. So it will become 14 here. But if you will begin to check right now if that follows with the max heap, no, does not, because there is a contradiction happen right there that 14 is actually greater than the head node of that, which will be the parent node of 14 is 5. So that really contradicts with the rule. So what you will need to do, you will be going to bring that up. So you will swap 14 and 5. So you will do the process here. 27, then 14, 4, then 5. So you will be going to also swap 14 and 5. Where's 14? Yes. Swapping them. It will become 36, 10, 27, 14, 4, and 5. So this will be the update of your max right now. So afterwards, you will also compare. 14 is still here, but the head node will be 10 for the parent node. So that still contradict with the max heap. So you will be going to bring up that up. So it will become 36, then 14, then 10, then 4, and 5. So 27 here. I'm sorry, we forgot to add here the 3 and 9. So update, and we're able to swap 10 and 14. You have to also swap them. So you just have to indicate 36, 14, and 27, 10, 4, 3, 9, and 5. So that will be your complete insertion. And since we're able to insert that in our complete binary tree. So after you were able to insert, since our goal is to sort the specific array using this heap sort. So we will begin to delete the specific head node that will be the largest number, and we'll begin to put that at the end of our box right now. So what will be the element that we'll be going to delete right now will be the 36, and that will be at your step 9. So in your step 9, you have to delete the root node. That will be 36. So in your 36, since you will begin to delete this specific element, so you cannot bring automatically the 27, you cannot bring that up. So what you will need to do, what will be the last element in your tree, that will be the element that you will also bring that in the, you will swap, or put that at the topmost of your tree. So since 5 is here, automatically 5 will be inserted at 36 place. So it will happen 5, then 14, 27, then 10, 4, then 3, and 9. So make sure that you will need to do it step by step. You cannot do it shortcut, since of course it will really affect your score. Now, what you will need to do here, you will update as well. Since 5, you were able to put that at the 36th place, so you will update your box right now. 5, 14, 27, the HEAP 5. So 10, 4, 3, and 9. This is the HEAP 5 box. So since we're able to delete earlier the 36, you can somewhat put a basis here that 36 already deleted. So that's not included in your Hipify box. That's already in the sorted place. So since you're able to delete the 36, and you will also check in this particular 3 of yours if that follows with the max heap. So since 5 is at the top most of your 3, then that's not following the max heap. So what you will need to do, you will bring that down and you will put that in the right place. So what will be the specific largest number in that specific 3? So 27 is the largest number, so you'll bring the 5 down, then 27 will take place. So what will happen here? 27, then 14, and 5, and 10, and 4 will become like that. Then 3 and 9. So you will update 27 since you were able to swap that into 5, something like that. You will also update that in your Hipify table, I mean box. So it will become 27, 14, 5, 10, 4, 3, and 9. So since we're able to delete the 36, I will put here something like that as basis that it's not included in your Keepify box. So checking the 3, it still does not follow the rule, since 5 is absolutely smaller than 3 and 9. So what you will need to do, you will bring 5 down, then 9 will take place. So you have to arrange 27, 14, 9 will go here, then 10, 4, and it will become 3 and 5. So since you were able to interchange 5 and 9, you will also update here 5 and 9. Sorry. So you will begin to swap their places: 27, 14, 9, 10, 4, 3, and 5. So assuming that that is the boundary of the Hipify and the sorted element. So this tree rate is already following the rule that is already in the max heap. So we will begin to move with the step 10, which you will need to delete another element. So the another element that you will begin to delete right here will be the 27. So by deleting 27, what will be the element that will take place in that certain place? Will be the 5 automatically. So 5 will be there, 14, 9, 10, 4, then 3. So you will update this one here, since earlier you were able to delete the 27. So 5 will take place. Then it will become 5, and 14, 9, 10, 4, 3, and indicating that this is the boundary of your EP5 box. It will become 27 and 36. So if you can check, if you can actually compare your sorted place, you can actually picture out right now that 36 and 27 is already in the right place. So in the latter part, it will be sorted accordingly. Once we were able to do the process recursively, it will be we could be able to sort that as long as we were able to follow the rule. Now here, by checking this theory right now, it does not follow the max heap organization. So what you will need to do, you will compare. So 14 will take place in the 5, so you will bring the 5 down. So it will become 14, 5, and 9, 10, and 4, then 3. So that will be the organization will happen right now. So you will update as well, since 5 and 14 was already, you were able to swap that. So what will happen in your VP5 box? become 14, 5, 9, 10, 4, 3. So it will be like that. So suppose that this will be your boundary right now. It depends on you how you were able to demonstrate that in your end. As long as there is a basis that we could also picture out that that's the boundary of your sorted and your heapify elements. So by considering this one, this tree right now, by checking 5, is it in the right place already? No, it's not following the max heap. So what you will need to do right now here, you will be going to bring down 5 and 10 will be taking place in that right now. So 14, 10, 9, then 5 and 4 and 3. So it will be that's how you will organize that. Then you will be going to 5 and 10 interchange them. So what will happen right now? It will become 14, 10, 9, 5, 4, 3. And then indicating the boundary, then 27 and 36 is already sorted as we did earlier. So this is actually following already the max organization. So what you will need to follow in the next step will be the 11. So the step 11 will be deleting the 14. So delete 14. What will be the element that will take place in that one will be automatic 3. So it will become 3, 10, 9, then 5, 4. So make sure that you will need to step by step the process. So 3 will take place into the 14, so it will become 3, 10, 9, 5, 4. And then you have to put the boundary. Then you put here the 14, 27, and 36. And afterwards, you will begin to check if that follows with the rule of this max heap, but it's not following the rule. You will be going to bring that down. 10 will take place with the 3 element. No, 10, 3, 9, 5, and 4. So it will be like that. So this is 5. So what will happen? 10 and 3, you were able to swap them. It will become 10, 3, 9, 5, and 4. So with the boundaries that you've identified earlier will be 14, 27, and 36 is already in the right place. Okay, now here you will begin to check still accordingly. 3 is at on the right place already? No, it's not. Since 5 is absolutely rare, then you will have to bring down 3 in that way that it will be following the max heap organization. 10, 5, 9, and 3 and 4. So by checking that 3, it's already following the max heap organization. That's okay already. So it will become 3 and 5. So you were able to swap them. So 10, 5, 9, 3, and 4 will become like that. So you were able to sort 14, 27, 14, 27, and 36. So since that is following the max heap organization, what you will need to do, you will need to proceed with the next step, which will be the step 12. So deleting element 10. So you will delete 10 right now in this one. And then 4 will take place with the 10. So 4, then 5, 9, 3. So it is exciting, right? So, what will happen? 4 are able to take place with a 10. Then it will become 4, 5, 9, 3. That's how you will do it. And you were able to insert here 10, 14, 27, and 36. So you were able to successfully put in place the 4 elements. Now, by checking into that organization, if that follows the max heap now, that's not following. So you will be going to swap 4 and 9 so that it will be good. 9, then 4, then 5 here, then 3. So considering that one, since you were able to interchange 9 and 4, so what will happen in your heapify box? Become 9, 5, 4, and 3. Become like that. So put the bases here, 10, 14, 27, and 36. Then afterwards, it will become here, what will be your, what will be the next step? It will become, you'll begin to check if that follows with the rule already, and yes, there's no problem anymore. So what will happen? You have to proceed with the 13 step. So delete. Okay. Delete 9. So what will happen? Bring 3 above. So it will become 3, then 5, and 4. So in that one, right now, 3 will be taking place into the 9, become 3, 5, 4. Then put that in a box. Then 10, sorry, 9, 10, 14, 27, and 36. And then afterwards, checking if that follows with the rule. Yes, no, that's not. So you will begin to swap 3 and 5. So what will happen here? 3 and 5 will be swapped. So it will become 5, 3, and 4. So we're going to redo the EP5 box. So it will become like this: 9, 10, 14, 27, 36. So that will be the basis. Then, since we're done with that, and that follows with the organization, become 14, delete 5. So it will become 4 will take place. 4, then 3. So 4, since 4, then 3, then you will add 5 here, then 9, 10, 14, 27, 36. So for this one right now, that follows with the organization. So there's nothing you will need to do. You have to delete number 4 automatically. Delete 4. And then for this one, automatic 3 will take place. So 3, then it will become 4, 5, 9, 10, 14, 27, 15, 27, 36. So afterwards, the last step will become delete 3. Then will become nothing already. So what you will need to do, 3, everything is already in place. 3, 4, 5, 9, 10, 14, 27, and 36. So that everything is already in place, and you have to just update for the final sort. Will become 3, 4, 5, 9, 10, 13, 27, and 36. So that's how you will do the heap sort. So I hope that you will begin to follow the same thing, the same procedure in the examination. So goodbye.